Hi everyone, I'm Ivan. I'm a PhD student at Tokyo Tech, and I'm going to talk about our efforts on automatic input generation. And this work is done with many people involved. It was done at Lawrence Livermore National Lab. So what we want to do is you have code like this, for example. You have your linked list and you have a function and it calculates the length and it sums over the elements of the linked list, right? But you don't have inputs for it. So you want to test its performance or you want to profile it, but you can't. So R2 allows you to just give it as an argument a LLVM module, which is the compiled version of this, and it will automatically generate input and run it for you. As we can see in these 2 runs, it managed to generate a linked list, an input of a linked list with length 4 and a length 12. So what exactly it does is you give it a LLVM module and you tell it, this is my entry point. And what you get is you get some generated input, which is a binary file of the input state and the output state. And it will also give you a nice driver, which will automatically load this state, and it will call the function, and it will check the output if you'd like. And we can combine this in a proxy app, which is relocatable, and it doesn't depend on your operating system, for example. And how exactly we do this is, for example, you have this function which takes a pointer and it loads some value and stores some value. So first we get all the side effects and we instrument them. So in this case, like the input pointer is in a way a side effect as well because we get it from outside. So we instrument the input pointer and then we instrument the load and store again as well. And what do we do if we need a pointer? Well, we'll just allocate some memory and we'll return the pointer to that memory. What happens if we need to load from that pointer? Well, we'll go and look at the address that we allocated so we know what's going on there. And we check, did we store something there already? If not, then, well, something has to have been, something must have been there. So we'll just generate some random value and we'll give it to the code. If something has already been stored there, we'll just return that. And what happens when you need to store? Well, you just execute the store, but you need to keep a separate region in memory which stores your initial state so as not to overwrite it. And now with this instrumentation in place, we just get a bunch of random seeds in a loop and we give it to the input generation runtime, which does all of the random returning and generating of values, and we run this code. And if we manage to successfully exit the function, well, that means that we found input. And we dump that input, and in this way we can explore various possible input states and output states. And this can be generated and bundled in one single proxy app. So what we did for our evaluation, and this is still a work in progress, so there's lots of improvements to be made. There's this work that of Compile, which is a data set of a lot of LLVM IR modules. There were a couple of talks that discussed it. And we run it on 50 modules from there, and we have 850 functions in that, and we managed to instrument 373 of them. So we lost almost more than half of the functions there. But this is due to some are still not implemented types, for example, structs or other instrumentation problems, which should be fixable. And then for more than half of them, we actually managed to generate inputs, and almost all of them run successfully. And for future plans, we plan to give hints to the runtime about the values that we request for it. Because, for example, we could say, we found that statically this is a loop bound, or this is a function pointer, so we can't just allocate address, we actually need to return a function pointer there, and various other things. Yeah, thank you. And feel free to talk to me Aiden here or Johannes there about this. Thank you.